So we've been talking a lot about Earth observations from the International Space Station this week, and one experiment's actually about to celebrate a very exciting anniversary, and that is the high definition Earth viewing. To learn a little bit more, I'm joined today by Carlos Fontenot, one of the principal investigators, co-principal investigators for the project, to learn a little bit more. So Carlos, first off, start me off, where did the idea for HDEV come from, and what was the original intent of this payload?
A few years ago, the ISS Technology and Science Development Office found themselves in a situation where there was a space available outside the Columbus module
Hmm.
where the payload had been delayed and the program wanted to utilize that space. So the Science Technology or Technology Office came to me and said, what about we put some cameras out there? What would it take to put some
Hmm.
cameras? So I drew on a little piece of paper. Well, we need a camera, an encoder, and then we need a router. We can put so many cameras in an enclosure, and drew it on a little piece of paper. And my colleagues went on their way. A few weeks later, I get a call. You are the principal investigator for this payload. We are going to build an enclosure and put it outside Columbus. And the design, build, certification, and delivery will be done in a short period of time.
Hmm.
And we broke a record 9 months from conception to delivery.
And so, what was the real purpose? I mean, it's more than just let's put some cameras on the station. What was kind of the scientific purpose for building this payload and putting it on the station?
Absolutely. As you know, the space environment and the radiation in space is very harsh to
Hmm.
electronics. So you may observe from time to time that some of our images have white little dots. Those are pixels that are missing because of radiation. And the sensors get damaged because of it.
Hmm.
So we are studying, we count missing pixels on the images, on the views, and specifically on the nadir view, we have seen a couple of pixels missing. But we're very surprised because we thought it would be much more. So the enclosure where the cameras are we think are partially protecting radiation from hitting these sensors.
Okay. And it wasn't just NASA people building this payload. You guys also got students involved, which is always very fascinating when you're a student to say, I built something that went into space.
Absolutely.
Tell us about how you got students involved.
Well, there's a program called HUNCH,
Hmm.
High School Students United with NASA for creation of hardware, I believe it stands
Hmm.
for. And these students participated with our team, and they built some of the brackets that actually hold the cameras in place and hold the encoder. So they built part of the little brackets, structural pieces that hold the payload. You can see here the payload. On the right, there is an enclosure. That's the finished payload, and those little windows that you see, the cameras are behind.
Hmm.
And those cameras partially are held by these brackets that the Hunch folks built.
Very cool. And so this video, so April 30th marks the 2-year anniversary of,
Yes,
activation
tomorrow.
tomorrow. So this has been streaming live the whole time, and students were even involved with the streaming of this video too. So first off, tell people where they can go watch this right now. And
Yeah.
again, how are students involved in this?
Well, you can watch this around the clock at http://eol.jsc.nasa.gov/HDEF.
Hmm.
You go to that website and you not only see the downlink, but you see the track of the station going over the Earth.
Oh,
So you
very
can
cool.
tell when the station is at nighttime. And unfortunately, when it's night, you cannot see much with HDEF.
Hmm.
But then, as you see the station come into the daylight, there is the picture.
Yes.
And so you can watch this around the clock. And we've had to take the payload off the air for several reasons, and we get calls. There are folks in Europe, folks all over the world, and they say, "Where is my HDEF?" Now there's other UStream also streams HDEF, and Ustream makes HDEF available to many people out there.
Hmm.
There is an outfit that builds little boxes that tell you when the station is coming above you and shows you the HDEF images. So there are several companies that have used HDEF, as well as museums, schools, and universities.
So how have schools been using HDev with students?
That's very interesting. We got a call from our partners in Europe and Germany in
Hmm.
particular, and they were very interested in developing materials, curricula for the students in their geography lessons. And what better than using live views from Earth and identify those land masses? Now, HDEF has limited capability, but you can control certain functions.
Hmm.
You can switch cameras, the forward viewing camera, the nadir viewing camera, the aft cameras, through just a workstation that's connected through our systems, and so you can command the cameras. So we partnered with the University of Bonn in Germany, and we schedule their participation where they can command the cameras. So the students command the cameras, switch cameras, and
Very
see the
cool.
results as they're flying over certain parts of the world that they're interested in.
Okay, well, so we're about to hit the 2-year mark. How has it been going? You mentioned you've only seen a couple of pixels. Have the cameras
Pixels.
held up as well as you thought? Are they
Much better than we
exceeding?
thought,
Okay.
exceeding every expectation. Now, radiation sometimes affects electronics, and we have encoders, we have switchers,
Hmm.
and we have had a few instances where all of a sudden the system locks up. We have not only seen that on the external payload, but also inside the vehicle with our television system. So we rigorously studied what happened component by component, analyzed the telemetry, and it was just a latch up, what you call a latch up. And so all we did is what you do with your computer when it freezes up. We cycled it, rebooted it, and in some cases powered it down, powered back up. Bingo, there it is.
Sometimes the simple stuff works.
Absolutely, absolutely.
So what's next for HDev? It's
Yeah.
been 2 years. How long do you think the experiment's going to go? And what's maybe the next step? Is there going to be an HDev 2?
Well, as I said before, the reason why we're on board is because a payload was late.
Hmm.
So that payload will be taken into space now with SpaceX 13. That is sometime in 2017.
Hmm.
And when this payload arrives, our HDEF will be taken robotically off the Columbus module, and the new payload will be placed where we were, and they'll bring it down. So I'm looking at the fall of 2017, year and a half from now, more or less,
Hmm.
and we expect HDEF to continue working the way it has been for 2 years. Now, when we bring down HDEF or take it off station, we have been looking at any places where we can attach a new payload, build a new payload.
Hmm.
However, there aren't very many places.
Yep.
We need data, we need power, we need certain requirements. So I'm thinking that rather than replacing the hardware, we may just replace the function because we're putting new high definition cameras. So we may just leverage the function of those cameras and train them to the earth when they're not being used and have that as a substitute or future HDEF. We're working that plan. It's not a done deal,
Hmm.
but that would make sense.
Okay. Well, again, the high definition Earth viewing cameras marking their 2-year anniversary now on board the International Space Station. Been providing some spectacular views, and they will be for only another year and a half. So if you haven't been checking them out, make sure you go do that right now. Carlos, thanks again so much for joining me. Always a pleasure to talk to you here in Mission
Same
Control.
here.
And great job with the experiment. We love it.
Thank you. Thank you.